Today, we are going to go over how to configure multiple MSC Nastran batch runs. My name is Christian Aparicio, and I'll be walking you through today's tutorial. Now, what we want to do is configure multiple local optimizations. In total, this will be taken as a global optimization. So this is what we've done so far. We have this Nastran model of an engine, and we have already configured it to use solution 200. Now what we want to do is perform this one local optimization multiple times so we can perform a local optimization in different locations, if you will. So it actually would be worth jumping out of the presentation and showing you this. So what do I mean when I say perform multiple local optimizations? So suppose that this function on the left, this response surface, is the objective function we want to find the minimum for. Here you can see that there are a lot of hills, a lot of low points, if you will. So we have to find the minimum here. If we were to perform, say, a local optimization, sometimes you'll just find a local optimization. Maybe you'll find this local optimization that's here on the left side of this response. So what we're interested is in finding the local, or rather the global minimum. So how do we go about doing this? What you can do is you can perform multiple local optimizations at different starting points. So here on the right, if we look at a contour plot of the surface, we will go ahead and start off with multiple points in this design space. Each of these points will be the starting points for the local optimization. So as an example, if we look at point 34 in this region, when the local optimization starts here at point 34, it's going to go towards the local minimum, which is at this point. The same thing will happen with point 6, point 12, point 4, and 29. They will go to this single local minimum. But if we were to start the local optimization in some of these points in this region, the local optimization will eventually go down to this local minimum. So here, what we're doing in this tutorial is we're going to take this optimization of the engine model, and we're going to configure the one local optimization to start at multiple different points. And then the best local optimization solution out of every optimization will be the global solution. So let's go and jump back to the tutorial. This is basically what I went over. There's some more details if you want to go ahead and look into this model in more detail. Now let's go over the problem statement. This is basically where any practitioner should start off with. This is a summary of the parameters or variables that will change in your batch runs. Here, what we want to vary are the initial values of the design variables. So we'll specifically modify the X initial field of the desvar entries. Now, in terms of our combinations, we're going to use the Latin Hypercube design or sampling method to construct our different points. And then at each point, we'll go ahead and start the local optimization. There are two responses we want to monitor. If you think back to local optimization, every local optimization has the following. Let me see if I can... Here, this is a good point. Every local optimization is going to have a plot like this. It's going to give you the objective versus the design cycle. So here you can see that we're minimizing the objective. So what we want to track is the last objective value after the optimization. We want to do this not only for one sample, but for any second, third, fourth, any other sample that we perform the optimization for. We also want to do the same for the final max normalized constraint. So it'd be worth showing you that in a moment. So those are the two responses we want to track. We want to track for every sample the last or the final objective value, and we want to track the final max normalized constraint value. Now, before I go ahead and start the tutorial, I'd like to point out that if you have any questions with Nastran Solution 200, if you have any questions with machine learning, you can reach me at this email address, and you can send me your comments, your feedback, or your questions. If you have any general structural optimization questions, you can also reach me at this email. If you want access to this web app we will be using today, you can also reach me at this email address here on the screen. Now, let's go ahead and jump into the tutorial. And what I'll do here is I will go ahead and navigate to the user's guide. The user's guide has all the tutorials and all the BDF files that you need to start any of these tutorials. So I'll go ahead and navigate to this tutorial, which is the global optimization tutorial, and then I'll download the starting files, and then I'll just extract the contents. And what I want to do now is I need to have a copy, or I need to have the H5 file type available. The H5 file contains the responses we need to extract for every sample in this tutorial. This will come into play in a moment when we, are configuring our problem statement, where we select our responses, the final objective value and the final max normalized constraint value. So if we open up the F06 file, let's just make sure that this optimization ran fine. So run terminated due to hard convergence. Okay, perfect. So this is what we want to track. We want to track the final objective value, which would be this value. So this is the, the final objective value after the optimization for this particular optimization. We also want to track the max normalized constraint value. For this particular optimization, there are no constraints, so that's why you get this not available value or term here. But when you perform your own local optimizations, and if you do have constraints rather, you will actually get a value here. But I want to show you how to track this later on. So now that we have the DAT file or the BDF file, now that we have the H5 file, we can go ahead and start our tutorial. So let's go ahead and navigate to the home page and click on machine learning. The machine learning web app, as the name implies, is capable of configuring machine learning optimization for Nastran. You can also configure it to perform batch runs, and that's what I'm showing you today. So to start off with, let's go ahead and pick all of our BDF files or DAT files, and when it reads in the BDF file, it lists every bulk data entry that you can use to specify parameters. Like if I wanted to specify this field as a parameter, I can do that. But here in particular, I want to focus in on the initial value for each desvar. So here, let's go ahead and just select these fields, and I believe we have about 20. And you'll notice that every time I click on one of these fields, and this only happens for the desvar entry, it automatically carries over the lower and the upper bound. So I don't need to configure anything at this point. So just to summarize what I've done here is I have set the initial values for each variable as parameters here. So this is setting me up to do the following. I'm going to configure Now that the initial values can vary, I'm going to configure each of these different points. So to do this, I navigate to the sample section. Here I can navigate to the land hypercube. If you really wanted to, you could maybe generate a new land hypercube design. The difference between these two is that say I perform a 10 run LHS design, and here you can see that the first value is 1.39. So maybe let me type in 1.39. The true land hypercube design is such that every time you regenerate it, it's going to give you a new design. So if you go back to 10 samples and you look at the first value now, it's now different from before. And if I was to go ahead and repeat the process, you'll notice that when I go back to the 10 run land hypercube design, my values are different each time. There's still a 10 run land hypercube design, but given that there's a randomization process in the LHS method, that's why you get a different design with different values. Now, here with the reproducible version of the land hypercube design, what I went ahead and did is internally there are a list of fixed land hypercube designs. So here, for example, for 40 runs, if I were to navigate away to 60 runs and navigate back to 40 runs, you'll see that the first value is the same. So the reason that this reproducible option is here is so you can replicate the results. Otherwise, if you use the other method, you'll get most likely a different solution at the end. So here we'll use the reproducible option just so we can reproduce the result here. So here I don't want to run too many samples. I want to run as few samples as possible. So what I'll go ahead and do is I'll download a CSV file. Maybe I'll only want to pick the first 5 runs to run. Yeah, let's go with that for now. So here I'm using Excel to customize the samples I want to run. And just to make sure, let's open up the CSV file in Excel just to make sure I have the 5 runs in here. Right, 5 runs. And then here I would switch back to the user defined option, and after this I would just go ahead and import the CSV file. Now if we look at the table, you'll see that I now have 5 runs configured with 20 different parameters. So these 5 points, if you can imagine that the design space now has 5 points instead of the 40 I started off with. So that's what's happening here. We're going to run local optimization 5 times at 5 different points. So after that, we have to identify the objective and the max normalized constraint value. So to do this, we'll go ahead and select the H5 file, and we'll go ahead and bring it in. And I have to select the data set that contains this information. So for this, it's going to be the optimization / objective. So here, what you could do is you could look for, or here you just select the exact objective value. And then for the max normalized constraint value, you just select the max sim column here. Now, it's very important that you select yes in this option that says monitor the final design, or monitor the final response of the design cycles. So what this means is that, let's jump here. You have an option. You have an option of selecting which design cycle you want to track. So here, as an example, do you want to track the objective at the first design cycle, or do you want to track the response at the final design cycle, or is there a specific design cycle you want to pick? That's what this means when you said yes. Yes, I want to monitor the last or final design cycle, so that's why both of these are marked yes. Here maybe let's go ahead and select minimize because we want to minimize this problem. So we'll go ahead and pick yes for that, and then I'll quickly glance over this, and that looks good. Let me go to the settings section, and here it's currently set to parameter study. Parameter study just means that we have configured multiple batch runs. Here we've configured 5 runs, each one with a different set of initial values for the design variables. Let's go ahead and download these files, and what you get after you click download is a single BDF file. This BDF file is going to contain all of the BDF files, and this is what we are going to use for this example. So let's go ahead and extract the contents. Once open, we'll go ahead and click start MSC or start desktop app. And so what's going to happen now is that this execution is going to perform 5 local optimizations, and then the best solution out of all the optimizations is going to be the global optimum, if you will. So I think, let me go ahead and see what I can discuss at this moment, if there's anything else I can do. So in a moment, I will go ahead and walk you through what's called the HDF5 Explorer, because you are probably going to want to look at the XY plots if this one had any. Or actually, right, we probably want to compare the, the objective values for some of these, so we'll do that in a moment. Right, so this one might take a few moments, so I think at this point I'll just go ahead and pause the video and wait until the optimizations are complete. So the last local optimization just finished. Let's go ahead and go over the results real quickly. So you get these additional web or tabs, if you will, that are open. Let me just go over what's happening here. So this first tab, if you will, this first page is giving you a summary of each local optimization. Here it's telling me that the best minimum was found in sample 5. The worst or the highest final objective was found in sample 1. We'll go ahead and actually compare these two in a moment. Here in this slide, or this page, if you will, it's showing me the response for each response I've selected. If you remember back in the machine learning web app, I configured response R1 and R2 for the objective and the max normalized constraint respectively, and that's what's reported here. I have R1 for samples 1 through 5, and then I have R2 samples 1 through 5. Here the max normalized constraint is NaN because this is an unconstrained optimization example, so there are no constraints to report, hence nothing is reported here. In addition to this, I get this window asking me to open the HDF5 Explorer, and this is what I want to do, but just for the first and the 5th sample, if you will. So here in a moment, I want to look at the objective history. So basically the objective during the design cycle process. Before I do that, I should highlight that when you open the HDF5 Explorer, it will go ahead and detect in your BDF file if there are any plots it can create automatically. And here it happened to automatically create a plot for me. So here what I can do is I can display the starting acceleration versus frequency plot at the beginning of the optimization for sample 1, and then I can display the final response for the final design cycle. So this is a before optimization and an after optimization for sample 1, and then I can repeat the process for the 5th local optimization. So this is the before optimization, and then this is the after optimization response. So now you may be interested in comparing the change in the objective for samples 1 and 5. How do you do this? So remember that we selected samples 1 and 5. So those two H5 files are in here. So if I look at the objective, I've selected the objective data set. You'll see here that I have objective values for not only model 1 H5 file, but also model 5 H5 file. So now we're looking at the contents of these two files. So we're looking at 1 and 5. So this is what we're looking at the moment. We're looking inside of these two H5 files. Now, if you want to create a plot using the data in this table, there's a button here you can click on. So I click create plot. In a moment, this will start flashing, last plot added. If I jump here, I now get a plot of the change in the objective for each design cycle. Now, here, the final objective value for the first sample is 15.61. If I go back here and I look at sample 1 here, which is this blue column, the objective value, the final objective value is 15.61. So now you know what's being tracked. We're tracking the very last value on this plot. Now for sample 5, we get a value of 9.16. And then if you look here at this purple column, this is 9.16. This is also what we get. So now you know that we are indeed tracking these last points of the objective. And then if you look here, we also find that the max is 15.6 and the minimum is 9.16. So I just wanted to show you that this is indeed what we're tracking, the final objective values of each optimization. Now this was a 5, or we performed 5 local optimizations, and now the best solution out of this is our global solution. If you do this, say, for 40 or 100 runs, comparing each bar might be a little difficult. So you get a little message here that gives you a summary of where the minimum is and where the maximum is. So if you look here, it's telling me that the minimum is in sample 5 and then the maximum is in sample 1. So you can use this when you have 50, 100 optimizations to quickly find where your global solution is. I think, let me see if there's anything to go over at this point. Nope, I think that's pretty much it for this tutorial. So I will go ahead and leave you off with the following. Like I mentioned at the beginning of the tutorial, if you have any questions with MSC Nastran Solution 200, which is the gradient-based optimizer, you can reach me at this email address. If you have any questions with Nastran and machine learning, you can also contact me. If you have any structural optimization questions related to Nastran, you can also contact me here. Now, these questions do not have to just be associated with Nastran. They can be with other finite element solvers. Also, if you want access to this web app that I showed you today, you can also contact me here. With that, I'd like to give you a big thank you. So yeah, we'll stop here.